This is Scaling Nagios Core in Amazon Web Services, and I present to you the founder and CEO of Bitnetix and SmartVox. There he is, Eric Loyd.
Thank you. So anybody who is looking for monitoring hardware with Nagios, the talk is completely canceled, so just to be clear. So I was asked not too terribly long ago, by that I mean at lunch, to fill in. So this is actually a presentation that I did at last year's conference. There really isn't much difference, to be honest, between then and now because I haven't touched it in a year. So some of this is maybe a smidge out of date compared to what we are actually doing today in real time with our corporate platform that we'll be looking at, but the concepts at least still apply. So the idea is Amazon Web Services and how to dynamically adjust how many of those services you're using in real time to adjust the cost of the service that you're providing, or how to pay only for what you need. So a little bit about my company, Bitnetix, and myself. I did make one change to this slide from last year. Scott will notice it at the bottom. So if you were here yesterday, I received one of the MVP awards, so I threw that in there. We've been using Nagios since 2004 to support our own internal infrastructure and our customers. Some of them are names that used to mean something, like Eastman Kodak. We're located in Rochester, New York, so these are Rochester-centric organizations for the most part. But we've been in business since 2006 officially, so that 2013 date was for last year's presentation. Bitnetix is a consulting company, and through part of that, we provided a very small number of our customers with voice over IP services. So prior to 2012, we were focused on IT consulting. Maybe 10%, that's probably a generous number actually, was voice over IP services and servers that we were providing to customers. Most of them were located at the client sites. This was not a hosted voice platform. And they were running custom asterisk-based servers. FreePBX was the interface for configuration management. And we ran those customers' networks because we were also their IT provider, so we had full control over the platform. In 2012, we kind of switched things around so that the consulting services stayed with Bitnetix. I'll get to that on the next slide. And we started this thing called SmartVox, and we started focusing SmartVox just on providing the VoIP solutions. We started making use of Amazon's EC2 virtual private servers. So the idea at the time was every customer, because we had boxes that were at the client sites, every customer would get an Amazon web server, or sorry, an EC2 instance to run their VoIP desktop telephones. And the only thing that the customer had to worry about was providing network bandwidth to get onto the internet so that their phones could talk to the servers. In 2013, this formalized into a product and a service and a business entity called SmartVox. You can read the list of things we did. So at this point, we're about to end our second year of existing as SmartVox. And what we did was we really did start leveraging every customer got their own server to support their telephones. Actually, let me back up a real quick second. So this is going to be a lot of discussion about voice over IP. And I don't want to make it specifically about voice over IP, but is everybody at least familiar with the basic concept of voice over IP? Is there anybody that doesn't know what I'm talking about? Okay, good. So the telephones that sit on people's desks need to talk to a registrar, need to talk to a proxy server that can communicate with the public switch telephone network to be able to make and take telephone calls. So what we did was we created proxies for each customer that was in the closest EC2 availability zone to the customer. And then if you imagine a map, whatever the data center was that was west of the one that the customer was assigned to, that one was their backup. And if you floated around the back of the planet, you'd end up back on the east coast of the United States. So there was always a backup proxy for each customer. There were media servers that we ran that this was to provide things like voicemail capabilities and transcoding between different codecs. This was located in zones that we chose based on the number of simultaneous calls, how many conference bridges were in use, inbound calling patterns, outbound calling patterns, et cetera. We took voicemails and call detail reports and we stored those in databases as opposed to text files, or in the case of voicemails, WAV files, so that the database could store the information, not have to be local to a specific server. So we could manipulate this platform to provide services kind of anywhere in the United States and around the world to customers in a way that hopefully was efficient to providing that customer with service, and then all the other customers as well. So quickly, AWS, it's a collection of cloud-based services, storage, DNS, content delivery, network, CDN, and the Elastic Compute Cloud, or ECC, or EC2, as most people call it. There are, again, this data was created a little over a year ago. I really didn't update it in the 10 minutes that I went upstairs earlier today. So these numbers, I think, are not quite accurate, but they might still be. There's basically 3 data centers. Amazon calls them zones, but there's basically 3 data centers that Amazon operates in the United States. There's one in Europe, there's one in Asia, or actually there's 3 in Asia now, and there's one in Sao Paulo in South America. So you can create a truly global infrastructure that is either redundant between the different data centers or that provides multiple services in those locales. There's persistent storage. These days it's SSD-based storage. There's IP address management. There's all kinds of great things that you can do with this if you architect your platform to make use of this technology. It doesn't have to be voice over IP. Netflix serves their content, for instance, is served through Amazon Web Services. So when the data center in Virginia, that is the main data center for Amazon, goes down, your Netflix subscription says, please wait, while you're waiting to watch Breaking Bad or whatever. The best part about AWS is you pay for what you use. And you literally pay for what you use. If it's up, you're paying for it. If you're sending data across a bandwidth link or network link, you're paying for that bandwidth. If you're storing something on disk, you're paying for that disk storage. If you're not using it, you're not paying for it. So you pay by the hour if it's up. You pay for storage if it's persistent, and you pay for bandwidth that I can't remember which way it is. It's free coming in, and you pay for it going out, or it's the other way around. I can't remember. But you pay for data transfers either in or out of AWS, but you don't necessarily pay for data transferring within the platform. So if you create your own platform in a virtual space within AWS, it can span multiple locations and still be one virtual network that you don't have to pay for that bandwidth between those locations. If you span data centers, you do. But anyway, there are 2 real kinds of instances that we're looking at. If you bring up an EC2 instance, which is a virtual server, processor, memory, and disk, you can run a temporary instance called a spot instance. And this is kind of like a marketplace that you can bid on an instance, and you can say, I'm willing to spend whatever the number is you're willing to spend, 5 cents per hour for running this instance because I only need this instance for a few hours. Maybe it's because you need to do a quick task that only runs for a few hours and then you don't need it anymore. Or maybe, as we'll see for us, we bring them in to do burstable resources. So when you don't need it, it gets terminated, you're not paying for it anymore. There are other more permanent instances that AWS offers, and those are either these reserved servers, or you can also have a third type called an on-demand server, which is very similar to a spot server, but the on-demand server generally has a longer lifespan. So if you do some math, depending on a number of features, including how big of a box you get, you could be running anywhere from 15 cents to about $2 per day for the actual server if you've reserved it and paid for a year or maybe a 3-year contract to have that box in use. If you're just grabbing a spot server, you could pay as little as 50 cents per day to run that server. You could pay $2.50 per day. It could be more, it could be less. It depends on literally what the market is for those servers in real time when you try to grab one. For our purposes, about 10 cents per hour is actually a fairly high rate for a spot instance these days, but that's what we use in our cost of goods analysis when we do this for business purposes. So when we talk about usage on our voice over IP platform, primarily we're talking about concurrent phone calls. And that means whether it's an inbound call to our platform or somebody on our platform making a call out to the rest of the world, we need to worry about concurrent phone calls. There's transcoding. There's a whole bunch of media that has to, media, whatever, things that have to happen so that we can catch whether or not they're putting in touch tones, things like that. We have to pay attention to that media stream. So concurrent calls are where the load gets generated on our platform. So we quantize how much we expect one server to be able to do in terms of concurrent calls. In our case, that's 50. So these media servers, which are in between all of our endpoints for the phone calls, whether it's the phone on somebody's desk and the phone out in the world, there's a media server in the middle of that. If we have if we have 50 concurrent phone calls, we consider that to be one instance. If we have 100 concurrent phone calls, that's 2 media servers, so we have 2 spot instances. It just scales linearly at 50 calls per server. Give or take, the bandwidth and storage required for that's going to add about 10% to our overall cost. And like I said earlier, we're only trying to pay for what we actually use and what we actually need. So anytime we reduce our usage, we reduce our cost, but we keep that extra money in our pocket, so don't tell our customers, because we don't want them to know. So why Nagios? I mean, we're at a Nagios conference, and here I am talking about voice over IP. Well, we've had a lot of experience doing Nagios, and oh look, our CEO is a Nagios. All right, I'll leave that alone. Nagios provides everything that you know about Nagios. It's a centralized monitoring service. It's got alerting, it's got notifications, it's got escalations, and all that good stuff that Nagios can do. Active checks, passive checks. I'm not going to talk about Nagios because you all know what Nagios is. A couple of great things, though, is it provides zero cost, assuming you're talking about Nagios Core. And up here, we can integrate with Twitter. If you actually were at my talk this morning, you saw in real time how we use Nagios to actually notify using Twitter accounts. So we don't have to worry about email notifications and who's actually on call versus not. You can just follow or unfollow the essentially on-call Twitter account for whatever aspect of the world you're interested in, and you either get the alert or you don't get the alert. So we don't have to manage an on-call type situation. But then we get to leverage a whole bunch of checks down here, and I'm not really sure if this acronym is correct, but Scott, maybe you can correct me. But with the Nagios Network Analyzer and the newly released Log Viewer or Log Analyzer, what's the official title? Log Server. Oh man, I got it wrong. That's what I get for doing this at 10 minutes before my presentation. There's a lot of technology that Nagios brings to bear here that lets you really see deeply into the service. So for us, this was very important because we could do custom checks and notifications. That was tying back in with Twitter for us. And we want to try to manage as few things as possible. So by cookie cuttering everything, I don't know if that's a real word, but I'm going to use it, making every instance look like every other instance as much as we can makes it easier to deploy and manage. So again, we were talking about customer premise equipment where we had no real choice over what equipment they were using. Sometimes you've got routers that want to enable helpful SIP ALG type things, if you know what that means, which usually end up being less helpful in true voice over IP applications. So there's a whole bunch of customer premise equipment problems that just kind of crept up as we started growing. So once we figured out how to do these sort of cookie cutter servers that we controlled, we were sort of migrating at that point into a hosted voice over IP platform where you've got a phone on your desk and that's it. You have no equipment that runs your phone service located at your business. You're using our services in the cloud at that point, which at this point is the Amazon cloud. So customer boxes and SIP endpoints, those have been all replaced now with EC2 servers. Those proxies that we use to actually route phone calls, and the media servers that we use to keep track of voicemails and transcodes and all that's been all kicked up into the cloud, into the AWS space. But we also wanted to monitor our upstream providers, the people that we send phone calls to, for instance. We're not big enough to be a level 3 communications, so level 3 actually does a lot of our phone calls. So we give them phone calls, we give Vitality phone calls, we give Bell Atlantic phone calls, et cetera. So we want to be able to monitor our links with them so that we can tell whether something has truly failed or if it's just failed for one customer or if maybe some aspect has failed, but there's still another way that the calls could be made. So if something's broken, but the overall service is functional, that's what Nagios is good at. So we need a way to be able to send telephones to customers without having them come to our office first for programming and for setup. So we developed a provisioning system, and a lot of it is based around DNS SRV records. And I'm trying not to delve too deeply into what all the acronyms are, but for those of you that aren't familiar with what an SRV record is, in the same way that DNS gives you the ability to say, here's a name, give me an IP address, an SRV record gives you the ability to say, here's a service, give me a port number. So an example would be that an SRV record for a web service would be port 80, for instance. In the voice over IP world, it's typically, I want to know what the SIP port is to connect my telephone to. It's almost always port 5060, but it also provides the host that you're going to connect to as well. So by using these SRV records, we can have our provider send phone calls to our border proxies, and then those border proxies figure out what customer we're supposed to send that phone call to. And we may have more than one customer proxy. We may have more than one border proxy. We actually do have more than one of each. So some border proxies basically are smarter than others, but their role in life is to figure out what customer gets the phone call. And it's based on what number was called. The number goes into a database. The database figures out who the customer belongs to. That determines, based on an SRV record, which media center, rather, is supposed to get the phone call. And whether it's supposed to go to voicemail, whether it's supposed to ring a telephone, all kinds of stuff that happens in the phone world, which we're just kind of going to table for the discussions here. So we have this fairly complex arrangement of proxies and servers that need to communicate with each other. All of that has to be coordinated because each telephone has to know, actually back up for a quick second, each telephone on a customer's desk needs to know which one of these proxies it's supposed to talk to when it wants to make a telephone call. Because this operation also goes this way. In order for a phone call to be made from our platform, it goes from a customer proxy to one of our border proxies to our provider. So this is a two-way communication. We have to keep track of where everything talks. So we made a provisioning database. It includes all the standard information that you would find about a customer. It includes where they are, if they have multiple locations, the number of phones, their voicemail boxes, et cetera. There's a process which occurs that is kind of skipped over here, but when an extract is done, when we say this customer is ready to be turned up or provisioned, then it figures out how many proxies this customer is going to need based on geography, based on number of phones, based on anticipated usage. It goes and creates SRV records within DNS for all of those proxies that it's going to create. Media server entries are added for each customer location. And phone provisioning information, which is data that actually gets sent to the individual phone to tell it which proxy and which registrar it's going to use. Those get created. And then it magically kicks out an order to our telephone provider to say, hey, we need 60 phones for a customer. And part of that, there's a reason there's an asterisk there, but I don't remember what it is anymore. The order processing that we give to our provider for telephones includes getting information back from them that has MAC addresses for the telephones. So then part of this, and I think that's what this asterisk was, part of this process is there's a return flow from purchasing the telephones that takes you back up into the provisioning database to tell you which phones belong to which MAC address for which customer. So this is all really automated, and by the time everything's done, the phones actually end up at the customer's site in about 3 days. Part of this process of creating the proxies and media servers and all this other stuff is we need to go create the server itself. So we create instances, and this actually talks about spot instance creation, but the same holds true for other types, reserved instances. So for registrars, which is what phones connect to so we know how to get to the phones, those are generally permanent registrations. For the proxies, which is where phones talk to the rest of the world, they tend to be the spot temporary instances. So what we do is we create a spot instance request with Amazon. That gives us back a request ID. We can then use that request ID to create a new instance that is based on an image that we've already packaged up. You can think of it as a virtual image that you've taken a snapshot for. So we use that snapshot to create these instances in the future. So we wait a little bit to give things time to settle. We query the request ID that we were given. That gives us an instance ID. We get the instance ID. It gives us the IP address. We go automatically update DNS, and all those SRV records are managed through DNS with server information. We update Nagios with the equivalent information. When those instances shut down and are terminated, there's kind of a teardown process that occurs there as well. So this process can sort of reverse itself. And that means when we're using it, we get billed for it. When we don't get used, when we're done with it, we're not using it anymore. You know what, this whole process to me sounds like a Nagios event handler. When something happens, I want to do something, and when something unhappens, I want to undo something. So our custom image that we put out there includes asterisk. It includes all the stuff that we use for the core functionality of the voice over IP platform, but then asterisk itself is also told to wait for calls to terminate, or sorry, is told to terminate after all the calls have terminated. So as long as it's being used, it will continue to exist. When asterisk exits, then the instance basically gets terminated. No more calls are being placed through that instance. Asterisk exits. When asterisk exits, the shutdown scripts start, and you're done. Your instance is dead. Same thing happens in reverse. Basically, when the instance comes up, the startup script start asterisk, and it starts accepting phone calls. So the same idea happens with the proxies. This is for, well, I'm getting ahead of myself. The platform basically adjusts automatically. The more it gets used, the more of these boxes get turned on. And when those boxes are no longer used, they turn themselves off, and they get told, or Nagios gets told basically that those boxes are no longer needed, and Nagios tears them out of its configuration. So because of that, our cost of goods sold adjusts appropriately, and we only get billed for what we actually need to provide service to our customers. So let's hook this all up into Nagios, right? We talked about spot instances. They're very useful for temporary things. If you're going to do a database backup, let's do it on a spot instance, copy that data somewhere else, and then get rid of the spot instance, et cetera. So anything that you want to do repeatedly, but not for a long period of time, is a great thing to do with a spot instance, which is basically what it says at the bottom here. So let's use Nagios for provisioning, for monitoring, and for capacity planning. Sounds like a great idea. So rather than going and actually creating instances, we just update Nagios instead. So we tell Nagios, hey, you've got a new host. And Nagios, this is actually a little bit outdated now. There's no longer a single file that we dynamically do updates to. We actually have a directory that contains things, so this is part of what's out of date. Nagios looks for a host that's up. If it doesn't find it, it fires off an event handler. The event handler then goes and looks in Amazon to see if the instance has been turned up or if it's just not running. If it's there but it's not running, it starts it, which lets us reuse instances that we have more permanent leases on. If it's not there, it will start it and create a new one. DNS gets updated because most of this information is sort of managed through these DNS SRV records, so we know where customer information goes. So we have very low TTLs, so we update things every hour, and they expire. The phone provisioning, so that each phone knows where to go to make its phone calls, is also managed through that customer database. So that extract creates HTTP-served configuration files that the phones get, and they know where to get them because that's part of the information that our phone provider will put in the configuration of the phone before they ship them. So we pay them $5 per phone to preload one line in the configuration of the phone that then goes to one of our central servers to download additional configuration files that tell the phones where to go. So we never have to actually touch the phones. So phone provisioning is handled exclusively through this extract and HTTP. We have a bunch of master and slave servers essentially to send this stuff to the phones, including activation URLs that they have to type in account codes and that sort of thing. So the entire process from, as it says there, signature to functional, meaning somebody signs a contract saying they want phone service, to actually having phones on their desk and having them work and be fully operational is usually it's 5 business days. And that's an entirely hands-off process from us. We don't have to touch anything. Nagios, from a monitoring standpoint, looks for all those hosts that it's been creating, or if it hasn't created them, it creates them, because it knows what's supposed to be in DNS. The SIP proxies are dedicated to each customer, so they're not temporary. But when we turn down a customer, which I'll be honest, we've never had to actually do this because every customer who's ever been a customer still is a customer, which is great. But we've never had to test this process in the real world yet. But in theory, if a customer leaves us, when we turn down the database records, all of this will get torn back down as well. Nagios is obviously looking at services and making sure that we have things running the way we want them to be running. If it notices that something is not reachable, again, DNS SRV records don't just tell you what machine to go to, they tell you what port to go to. So we can manipulate our DNS infrastructure fairly quickly to reroute traffic through our platform so that it will literally route around entire network outages and still be able to send phone calls and deliver that data. Of course, we store stuff for capacity calculations. We send Twitter alerts and email as a backup, and that was basically my morning talk this morning, so I'm not going to talk about it here. And because of the capacity planning, we know we are looking at 50 calls per server that we want to have used by our customers in real time. This is basically a big slide talking about we have a process that goes and looks at historical usage from Nagios history and says, what's our delta in terms of call usage? Are we going up? Or are we going down? And there's an event handler that fires that basically says, if our state is okay, we don't really do anything. If our state is getting to the point where we have too much capacity, which we treat as a warning just because, then we say, whoa, wait, we're paying for stuff we're not using. Let's go figure out what we can turn off. On the other hand, if we're using capacity that exceeds, or if we're using calls that exceed our capacity, we'll start turning up new instances using the automatic provisioning. So our capacity, again, and the costs associated with it, dynamically change in near real time to account for actual current usage. So this is all talking about this process that talks about or that looks at the delta calls, which is why it's called delta C. But basically it looks at the last couple times it's run, it's tried to figure out whether we're growing or whether we're shrinking, tells Nagios appropriately to stop an asterisk server, or through an event handler, it tells the asterisk server to stop when it's done processing phone calls. If it knows it's going to turn that server down, each server terminates itself when the asterisk process exits. So if you tell asterisk, don't take any more phone calls, the phone calls that it's currently processing finish, it exits, and then the machine tears itself down, and then Nagios removes it from configuration through a pruning process that takes place. So Delta C is our big event handler that does a whole bunch of weird things. This is minorly out of date, but still sort of accurate. This is how you basically create those spot instances. Assuming we're going to create a new host, you basically have a big old command line here that says we're going to create a new spot instance. This is the snapshot that we're going to use from a previously created host. I don't remember what all these things are here, but oh, this is the price we're going to pay for it. So we're willing to spend 4 cents per hour on this host. If we can get it for that, great. If not, there's an error code that returns that lets us know that we couldn't get it at that rate, so we bump up the price until we get it for what we want. So we're always paying the least amount, basically. The security key that we're using for SSH to log in, this gets identified through AWS's interface. The security group for firewall rules within AWS is something, again, it's pre-programmed within the dashboard for EC2. The instance type that we're turning up, this is a medium box. There's nothing really special about it. It's your average virtual server from Amazon. We're turning up 1 box at a time. This could be 1, this could be 10, but we're only turning up 1 at a time. And the type of machine is a one-time machine, which goes along with the spot instance, but it basically says, we're going to only use this until we don't need it, and then when it's gone, I want you to terminate it and not bill us anymore. It's the bottom line. From this, we get a spot instance request ID, which we then go ask to get an instance ID, from which we go ask to get an IP address. It's kind of like pointers to pointers to pointers. And eventually, we get an IP address, and both a public IP address and an internal IP address. We populate those DNS entries automatically. We dump, I did actually update this line. I guess I didn't catch the earlier one there. But instead of updating a dynamic host.cfg file, which is what we did a year ago, now we're just dumping a host configuration into this directory. And the Nagios config file has been told to process that directory as configuration entries. So it processes each host file individually. The hosts have host groups that determines what services are going to be run on them. So this is all about a 30-second operation to turn up the machine and basically reload Nagios with the appropriate host information. And then when that instance spins up in about 2 minutes, Nagios is already there waiting to start monitoring it. So our Delta C saves money, not lives. A small usage change will make a small change in cost of goods. I'm not really sure this slide is entirely accurate anymore. but basically it says we're scaling our platform with our current usage. So if it's the theme of the talk, right? If we're not using it, we turn it off. We don't have to pay for it. If our customer base is starting to make phone calls, we don't have to actually look in real time to see, hey, do we need to go turn up another instance? Do we need to go plug in some more hardware? Do we need to go add some more disk? Because it's all virtualized and it's all automatic through a CLI interface, which Nagios can then access through an event handler, that means Nagios gets to determine how much we're going to be using on the AWS platform simply based on that 50 concurrent call number. If we decide for whatever reason that that's not a good number and we change that, if we make it smaller, then we're going to be turning up more boxes. If we make it bigger, we're going to be turning up less boxes. So we can adjust that as we get the sort of the feedback information from Nagios over time. We can determine, is that 50 still a good number? Should it change or whatever? And that's kind of it. So I apologize, there's a lot of sort of voice over IP terminology in there, but the idea is event handlers are your friends. The talk that I was going to do downstairs earlier on Nagios bloopers, my tagline was actually that event handlers are your enemy, because if you don't control them, they will do some really weird things. But if you have well-defined goals with what you're trying to accomplish, and you have APIs like what Amazon provides you, you can really have Nagios do some pretty cool things with dynamically adjusting just about everything that is your core infrastructure. So, any questions?
There's got to be a couple questions after all that he went through to do a second presentation.
There's one.
All right, perfect. Scott, you saved it.
Eric, do you ever run into a situation where you're bringing spot instances up for the proxies, and then, say for example, they forcefully tear them down or terminate them because the new spot market rate goes beyond that? Do calls just get routed to a different proxy, or do calls get dropped? How does that work?
Well, I'm going to answer that in kind of two different sections. So the first half, do we ever have spot instances that get terminated because they've exceeded the pricing? No. Now, the reason for that is because we actually planned ahead, and you never know what the spot market is going to be in terms of pricing, but it doesn't ever really, for what we're doing, it never really changes too much. So when we make those requests for what we're willing to pay, we're actually, the 4 cents is, I don't know why it says 4 cents in there, because it's actually pretty small. Like I said, we expect a 10 cent per hour rate. So we're willing to put a 10 cent per hour rate up there. Most of the time, the rate is 3 or 4 cents, maybe 5 cents per hour. It's sort of like eBay's proxy bidding. You might put your bid up here, but if this is all you need to actually get the resource, then this is all you're charged. Now, if the resource expense over time rises to the point where it's above what you're willing to pay, you start getting instances that are going to be terminated. In our case, if that were to happen, what the termination protection on the machine says that we actually get a little bit of notification that we're going to get some termination. So what we can do is this is not implemented, but there's no reason why we couldn't do this. We would get notification that a particular instance is about to be terminated. We would know what customer that belongs to. We can spin up new instances if we need to, or we can just sit back and let it terminate. The idea is instances grow when we've got more than 50 calls on another instance. So when the first instance hits those 50 calls, we're bringing in a second instance. And that might be 51st call and the 52nd call, but quite literally, if those two calls end and we're back down to only having 50 simultaneous calls, we're terminating that instance. So in many cases, our instances are only up for a few minutes, really. They're only running long enough to provide what is essentially a burstable resource at that moment in time. So if we've got 50 calls, that second instance is essentially temporary. Unless it's 9 o'clock in the morning and our customers are starting to use their phones. In which case, well, 50 becomes 100, 100 becomes 150, now we're at 250 or whatever simultaneous phone calls. So we need those 5 instances for the first few hours of the morning. Then it starts to drop off as people go off to lunch and they get terminated. For the most part, we run one instance, excuse me, we're running one instance between the hours of about 8 p.m. and 8 a.m., give or take. It's not making very many phone calls. Most of our customers are sort of 9 to 5 business to business type customers. So, they don't have anything going on after hours. So it really is, it looks like, a daylight curve essentially of what our usage is. And it's got some spikes here and there, but they tend to be fairly temporary.
Perfect, thanks.
Yep.
So if you're running 50 instances and that 51st and 52nd call come in and that instance isn't up, that new instance isn't up yet, you don't not let them make a call, right? You're putting those on the previous instance until...
Correct.
Okay.
Yeah, we don't have a limit of 50 calls. So that 51st call comes in and it hits up against some sort of hard threshold where it can't make the phone call. We're looking at number of simultaneous calls. If it's 50, we're going to turn up a new box. If it's 48, we're not. That 51st call that comes in before that new instance gets spun up is going to go on the first instance. The 52nd call is probably going to go on the new instance. So it's actually an aggregate number of how many calls do we have across the platform. Divided by 50, that's how many servers we need. It doesn't mean that we're only going to allow 50 per server. But as we bring them on and take them out, they will average themselves out over time, basically.
And then you stop putting calls on the next server when the previous server can field calls again? And that's how you control it so that calls drop off?
Correct. So are you familiar with Asterisk in any sort of way? All right, so it's a phone switching software that has a lot of capabilities, but one of them is the ability to say, I will continue doing what I'm doing, but I will not accept any more phone calls. So what we do as part of that turn up is we're actually telling the other boxes as well. I mean, there's a lot of work that goes on here. It's not really part of this, but we're telling the other boxes, I know there's another service or another box that's able to provide service, so I'm going to tell the other ones, don't accept any more phone calls. Now, one of two things will happen at that point. If they're not accepting any more phone calls, the load will shift to the new box. When these calls start terminating, eventually it'll get down to 0. And when our Asterisk servers are serving 0 phone calls, the Asterisk process exits. When the Asterisk process exits, the machine terminates. So we may not have the same machine providing those calls throughout the course of the day, even if it was always greater than 50 calls. Because they will come in and they will go out and they will change throughout the course of the day. It's almost like, switching players out on the field. You may not always have the same guys playing, but you're always moving the ball down the field kind of thing.
Well, it sounds like you have a pretty big dependency on AWS. Do you have agreements with them that if their service is out and it doesn't work, that there's penalties and that kind of thing? Or do you guys just bite the bullet if there are outages?
There is a dependency on providing service through AWS at the first level, basically. If things aren't working, there are backup registrars and backup proxy configurations on all of our devices that tell them to go to physical hardware that we have in 2 data centers. So we can still provide service even if Amazon's turned the switch off. It's not as robust, it doesn't dynamically adjust, it's not even running necessarily at full capacity at any given moment, but there's monitoring that's coming out of those data centers looking at the rest of the AWS platform, and if it sees things start to disappear, critical services start disappearing, Nagios again there, starts turning up critical services on physical hardware. So we can route calls to data centers. There's a data center in Rochester, there's a data center in Denver. We can start routing calls there as Amazon is dying. We can't route a call in progress. Every war has some casualties, I guess. But any new calls can be routed to these other platforms as we need to, not quite as robust as what Amazon allows us to do, but if Amazon is starting to die or a data center has disappeared, the rest of our platform knows about it. The other thing is, at the very beginning, I talked about each customer having a proxy in their most closest geographical region and then a backup in the one to the west. So assuming Virginia and California don't die on Amazon at the same time, customer calls will route through California instead of Virginia if Virginia is out of commission. And conversely, if they're connected to California, it wraps around back to Virginia.
Any more questions? All right, well, with that, once again, a big thank you to our speaker for stepping up and filling a void. Ladies and gentlemen, Eric Loyd.
Thank you.